Welcome everyone to today's webinar about the design of reinforced concrete structures using the advanced design. In your screen, you will see the team chat where you can pose your questions, and I will be happy to answer to all of those. In addition, you can provide your feedback. Your feedback is very important for me and my colleagues. It makes us provide better services. And of course, you have the demo, so you can request a demo if you want for the advanced design. The webinar is about to start.
Hello everyone and welcome to today's webinar, which focuses on the analysis and design of reinforced concrete structures using advanced design. My name is Evelina Balkanoglou and I am a structural engineer with an experience in different projects around the UK, and I also hold a PhD in computational mechanics from Loughborough University. Together we will see how to create a model of a reinforced concrete structure in advanced design and analyze it effectively and efficiently. We will also see how typically design modules of advanced design either in connection with advanced design or separately in order to facilitate the reinforced concrete analysis and design. This is the building we will be working on today during this webinar. Advanced design allows for categorizing your structural elements into different subsystems. These different subsystems can be created based on different criteria, such as the type of elements, different floors, etc. Clicking twice in a subsystem, you can hide it entirely, and clicking twice again can bring it back. Using the subsystem subdivision, as well as the copy feature, I am going to create one more floor on top of this existing structure. First, I need to go to the subsystems of the first floor that I would like to have on the
Apologies for any inconvenience. It seems that there is some sound difficulties, and some of you can hear me talking throughout. So I suggest we can have a 2 minutes break probably to sort this out, and we can come back and start again with a better sound quality.
Together, we will see how to create a model of a reinforced concrete structure in advanced design and analyze it effectively and efficiently. We will also see how to use the design models of advanced design either in connection with advanced design or separately in order to facilitate the reinforced concrete analysis and design. This is the building we will be working on today during this webinar. Advanced design allows for categorizing your structural elements into different subsystems. These different subsystems can be created based on different criteria, such as the type of elements, different floors, etc.
We will see now how we can have, using the copy feature on the advanced design, another floor on this existing structure is very easy to be done in advanced design. And as I see on, you can see on the screen, with the subsystems the advanced design has, you can copy easily all the structural elements from one floor to the other and basically have control on the structural elements you have on the structure, adding, copying, deleting easily throughout the process. As we create the second floor, I define the levels first. So in this case, the second floor is 3 meters above the first floor. And now, because I want on the second floor basically all the same elements that they exist on the first floor, I start with the columns. So I select the columns and I copying them, selecting basically the vector, which is pretty much the height of the second floor where my columns want to be. I select also the subsystem my columns will be copied to, and I can preview to check if the columns are copied on the same location, and I move on to the next structural element, which is in this case the beams, and I will do exactly the same process. And finally, I will do the same for the slab. And in a matter of seconds, we can create a second floor and in addition, a third floor, and basically create a multi-story building in a short period of time. Before running any analysis, we need to add some loads. The advanced design supports a wide variety of load cases. You can see dead, live, seismic loads. We also have crane loads, traffic loads. I will add only dead and live in this case. And I will add the dead and live loads on the floor I just created by selecting the slab of this floor and adding the loads. I select the load case I want to this load to be added, and I define the magnitude. And I do the same for the live loads as well. Then I need to create a set of combinations. This can be done really easily in advanced design, selecting the simplified combinations button, and a generator creates all the combinations needed from the Eurocodes in order to perform an analysis and design. So this can be done in a matter of seconds. Normally, before running any analysis, it's important to check the mesh options. So In this case, as you can see, the default mesh size is 0.25. This corresponds to all the elements on the structure. And I will keep the default size for now. However, if you would like to have a different mesh size for a particular element, you can click on the element and select from the corresponding tab the mesh size for this particular element, and this will change for this element or for a group of elements accordingly. After finishing this, I am ready to run an analysis. I will run an analysis first and then the reinforced concrete design. The calculation has finished. We have different ways to display the structure now. We can display the mesh, we can display the nodes. If we want, the advanced design is a very user-friendly software, so we have different ways to display the structure and as well different ways to display the results. In this case, I prefer to get rid of the mesh so we can see the structure elements and the structure as it is. And we will be able to post-process the results now. So basically now I'm hiding all the slabs in order to plot the bending moments for the linear elements. So I select the combination, the ULS combination, and as you can see on your screen now, is the bending moments for all the linear elements in the structure. As mentioned, I have hidden the slabs. There is a contour plot on your right-hand side where we can access the magnitude of the bending moments. Removing the columns now, hiding, I prefer this term better. We can now see the bending moments on the beams only. And bringing the slabs back, I am going to plot the bending moments for the slabs now. So I can show you how easily we can access the results for the 2D planar elements. This is the bending moment on the slab of the second floor. And as you can see, you can generate your results quite easily, effectively, and in a matter of seconds without losing any time. We can also see the deformed shape of the structure. So selecting displacements for any combination, we can see the deformed shape, in this case, for the slab of the second floor, because I was selecting the slab. But we can also access the deformed shape of the entire structure. And this is quite illustrative. to have access easily and quickly. And also you can do the same thing for different combinations. You can access it for only the dead or the live loads. Another nice feature is the result curves. They can be used for the linear elements or the cut sections you can have on, for example, on a planar element. And in this case, you have the option to create the envelope of the parameter you have initially selected. So it's a great tool to create the envelopes of certain elements, and you can easily export the data in an Excel file for further post-processing if you would like. In this case, we see the envelope of the bending moments for a selected linear element for a beam. Selecting a column now, we can see the bending moments for this column as well. And in this case, I will add the values on the diagram, which basically plots, apart from the contour plot you have on your right side, the values on the diagram, so you can access the maximum and minimum values directly without checking the contour plot for more descriptive plot. And after finishing the post-processing options you have in advanced design, we can move forward to the reinforced concrete design. So first, in order to perform the design, we need to assign some design options. There are two different ways to do the design options. Either you can create a design template for each element, as you can see here, columns and beams. Basically, in this template, you define all the assumptions you would like to take into consideration when running the reinforced concrete design. And after creating the templates, you can easily add those templates on an element or on a group of elements by selecting the element or by selecting the group of elements. This is the dialog where you apply the design assumptions. This is very nice because basically you can group all the elements and assign the design assumptions. The other way to do it, if you don't want to create any design templates, is of course to select the element or the group of elements directly and add the assumptions on this pop-up window that is being created when you select the element, and you add all those assumptions here. The last thing before running the reinforced concrete design is to check the design settings. For now, I will keep the default settings. The settings has to do with the beam and column calculation in terms of the reinforcement applied, and in order to, and some other effects, for example, cracking and punching shear, in order to be considered or not. For now, I'll keep the default settings, and I will run the analysis. The reinforced concrete design. The reinforced concrete design pretty much does the finite element calculation again, so that's why you see those areas selected. And normally the reinforced concrete design is affected by the number of elements used or the mesh options. Normally, it doesn't take too long, as you will see. You can access your results quite easily and effectively, and quite quickly, I would say. As I said, the design might take a few minutes depending on the mesh size. I have decided a quite fine mesh in order to get as accurate results as possible. So that can cause this kind of delay, but still, it doesn't take too long. It's always below 5 minutes, depending, of course, on the amount of the structural elements used and the size of the structure. But still, for this structure, it shouldn't take more than 5 minutes or 7 minutes.
The reinforced concrete design has been performed. I am getting some warnings, as you can see.
The reinforced concrete design has been finished. We get some errors. These actually they are warnings, which means that the design has been gone through. These warnings has to do with the crack opening, and we will come back later to those, and we will discuss how we address cracking in advanced design. We get those warnings. I can give you a short explanation because I didn't apply the cracking correction when applied the assumption for reinforced concrete. So the software gives you a warning in terms of the excessive cracking on slabs and columns. However, I will show you later how we will get rid of those and have I will show you the options we have. We can now access, when we run the reinforced concrete design, we can access the amount of theoretical reinforcement for an element, as you can see on your screen now. So I'm plotting the reinforcement for the slab of the second floor. And this is the theoretical amount of reinforcement needed for this element. And
I can access the reinforcement on the linear elements as well. I have clicked this column.
Normally, we can see the reinforcement for the columns as well.
And I can see the theoretical.
This is again the theoretical reinforcement.
I can do the same for this beam.
And we can see that for a beam as well.
And this is the theoretical reinforcement.
You can get this nice contour plot where it shows you the different amount of reinforcement needed. However, as I said, the theoretical amount is not the real amount, the real amount of reinforcement added after all on the element. And we will do that and I will show you how we generate the real reinforcement using the advanced modules, the advanced design module for each particular element. So I select the column, I'll start with the columns,
Export.
and I will
In
export
this window open,
this on the design module for the columns in order to create to generate the real reinforcement now.
as we can see on the screen,
As you can see
no
here, no reinforcement
reinforcement
has
has been
been generated
generated
for
for
the
this
column
particular element.
yet,
So
and we will do
by
this
clicking
now.
calculate,
Clicking calculate, the reinforcement for this
the
element
reinforcement
is
for this element
generated.
is generated. On the
On the
right hand
right-hand
side,
side, moving the cursor up and down, we can see the
we
different
can see the different
section
sections
of the column
where the reinforcement is
with the
generated.
reinforcement generated.
Additionally, we can modify
And
any
additionally, we
parameters
can modify any parameters corresponding to the reinforcement using the dialog box on the
reinforcement
top with the
assumptions.
reinforcement diameters and reinforcement assumptions.
Clicking on the
So
reinforcement
by
assumptions
changing, for example, the
longitudinal
diameters I would
coordinates,
like to have for the longitudinal reinforcement and clicking some of those and clicking OK,
loading the design
the
parameters,
reinforcement, clicking again
I
calculate,
can
is
see that
changed
the longitudinal
instantly
reinforcement now
in
is
this
changed.
module.
Clicking on the reinforcement assumptions,
I can change
I can
the
change
space
the
between the
space
links as
between the
well
links
using the reinforcement
or I can
assumptions
change
on the
the
dialog box. And I have so many different
size
options to play with in terms of the generation of the reinforcement
and by clicking
for
OK,
this
the calculation
column.
starts again in order the new assumptions to be applied on my
And
design.
basically, you
This
have to
module
calculate
is
by
called
clicking calculate.
Structural Engineer
You
for
can
Design Module. It allows you to
update
create the reinforcement
the
techniques directly after finishing
the
the
um,
design without losing any
the
information.
reinforcement on the
This allows
column.
me to less manipulate
This module
different
is
designs and see
quite
everything
important
the
for a
options
structural
available.
engineer because
An
allows you
interactive
to
drawing
create
is
the
presented.
reinforcement drawing directly. As I show you from the results, you can select drawing
This
and
drawing can be modified by
an
pressing the
interactive
F
drawing can
V
be
bar
created. You can
icon below,
edit
allowing the
the,
designer to change
the
the
bars
reinforcement
whenever you want.
anytime they want
And
without launching the
because the
calculation
drawing is
of the full
interactive,
structure
you
again.
can
An interactive drawing of the reinforcement
it
saves
is
so much time
updated
from structural engineering.
without
This
having
allows
to launch the
everyone to do
calculation of reinforced
reinforcement
concrete
using this
design
feature, and any
again.
modification can be performed in seconds, allowing the structural engineer to investigate many different reinforcement generations and decide the one that satisfies their needs. Going back to the model section,
On the model sections, we can access
there is another
other features
important
as well,
feature of this module.
such as the
This is the
backlink
backlink
feature.
that gives you the information about the backlink length of the column along both axes and
And
sides of
selecting
the page.
these
This gives you the
icons, you can
opportunity to
access
set the
the
backlink
backlink
length of
length
your
for the
vertical
column
elements and modify the
using different
calculations accordingly.
assumptions
By clicking
and
on the
based on different
diagram
assumptions,
icon,
and you can assess this. On the result section, you can
you get the
have
internal forces
diagrams of the bending
under the
moments,
column,
of the shear, of the axial force on the
charts,
column,
and you can print
and you
these
can
graphs.
assess them
I'm
as
going
well
to
for this
specify another
particular
feature of
structural
this module
element.
that always fascinates me, and this is the interaction curves of the
There's also another
result
feature that I
bar.
really like a lot. This is the interaction curves
For this
feature.
column
So by
example,
selecting
we can
this feature,
assess
you
very
can
easily the
see
interaction
the
surface at the
interaction
tip
curves
of
for
the
this
left-hand
particular
side. And
column
then
and
on the right-hand
see
side,
that
we can
all the
specify all
combinations
the load
lie
transmissions to produce forces and bending
inside
moments,
the
but they
interaction
are all
curve.
inside the interaction curve.
And I find this feature quite descriptive because it allows you to have more in-depth and illustrative idea of the stress rate of the column
This feature
and
is
whether it's
focused on
highly
creativity
compressed or
since
too
it
large
allows you
bending
to have
moment
a
is
more
applied.
in-depth
So you can modify
investigation
your design
of the
accordingly
stress
if there is
rate of
any
the column. For
external
example, if it is
limitation
highly
in
compressed or
place.
too large bending moment is developed, modifying your design accordingly if any external limitation is in place. To conclude, all those information can be easily
You
read
can
in the
access all those information and
report by
have a
clicking the
report
icon
generated by
generate.
clicking the generate
Let's design a
icon.
beam now. We can select any of
We will
these. They're
decide,
all continuous
we will
beams.
design a beam now.
And there are
So
different
we will
design
select
parameters
any
that
of
an
the
engineer
beams. They are
considers.
all continuous.
So first of all,
So
let's
before
see
we design it, we will see how
reinforcement, theoretical
the
reinforcement.
information we can access before proceeding
We
to the
can
module.
see the
As
contour
we saw
plot.
before, we can see the
We can add
reinforcement, the
values to this
theoretical
contour plot
one,
as well.
and
Easily we can shift different values as the reinforcement develops along the length of the beam. There are a few other parameters
there are some
that
other parameters that
are less important than
they
the
are
reinforcement,
important
but
and you can
still
access them
they
from this
can provide us
interface.
with a lot of
Is, for example, the
information
concrete
about
stresses or the
linear
reinforcement
elements
stresses
that
for
can
this
be
beam.
accessed
And I
using the reinforced concrete
found them
design
quite
designs. One of these is
important for
the
an
concrete
engineer
stresses
to be able
on
to
these linear
access
elements,
those information,
as well as
because
the
you see the concrete stresses
reinforcement
now on your
stresses on
screen
this element. And
and
this
the steel
information
stresses
is
now.
quite
And as I said,
important
this
because
information is quite
an
important
engineer or a
because you can
designer
modify your
can
design
modify their design
having
or
this
add more
information if you think that
reinforcement
any of these
if they
elements
believe
is
that any of these two
highly stressed.
elements is highly stressed. Another parameter that is quite
We
important
can also
for the
access
linear horizontal
the
elements and
cracking
slabs
width
is
on
the
this
cracking.
beam
So
as well.
we
You
can
can see
get
now
information about the
the
crack
width of
opening
crack opening
and
in a
crack
beam
width.
on this particular beam, and you
For
can
the
have
group of
information
elements,
about
advanced design normally
the cracking on this beam.
perform
As I
certain
mentioned before, we will
operations
come
in
back to
order
this,
to
and I
modify
will
and
explain and
evaluate better
support you
the
how
opening
to deal
when
with the
adding
cracking in advanced
reinforcement.
design,
So
specifically for these elements that they
asking
are
for
prone to
correction
cracking,
of
slabs
the
and
crack
uh,
of
beams.
cracking when you design the element before applying the reinforced concrete design. I will show you later and we will discuss. The generation of the beam reinforcement is straightforward too. The advanced
We
design
will see now
reinforced
the
concrete beam
generation of the
module is
reinforcement
used
for a beam.
again.
A
A similar
similar
interface
module
is on
is
the screen.
used for the
And
beams
after
as well.
assigning
You
the
can see that the reinforcement
reinforcement
is not generated
assumptions,
yet. Again, we have to assign certain
assign
assumptions.
here or
I'll keep
change
the
the
defaults
reinforcement
here
diameters,
in order to show you how this module works.
we can
And
calculate
by
easily the
selecting
reinforcement for a horizontal
calculate,
linear element too by pressing calculate.
and the reinforcement is generated in a matter of seconds, again for this beam. And pretty much the same properties apply for this module as well as the ones we discussed for the column. So again, you can change
Then on
and
the
modify
right hand
parameters,
side,
and
moving
by
the
pressing
cursor up and
calculate,
down,
you will have
we can see the
these
different
assumptions applied
stances
directly to your
save the assumptions for
element
each span. We can
without
also see
any need to launch any
here and
calculation again.
obviously on the
And
left
on
hand
the
side,
left-hand side, moving the cursor
moving the
right and
cursor
left, we
and
can
see the
access
different
different sections of the beam and see how the reinforcement is generated in
reinforcement
any of
is
those.
generated. This particular module is very useful for a structural engineer or a designer,
As
as it
I
can
mentioned
provide
before,
us
is
with
a
so
very
much
nice
information.
module. It's
First,
very
from
important
the
for an
results
engineer
found,
because you can
we can
access many different
access the diagrams for the bending
information,
moments
as I will show you. So, for
and the
example,
shear
you will see the
forces
bending moment
of the
and
beam
shear
and
force
compare
diagrams,
them with
and you
those
can
of the
compare them
reinforcement,
directly with the
assessing the
reinforcement
reinforcement
diagram
suitability and modifying
on this
the
beam,
opening
and
according
have
to our
a
satisfaction.
more in-depth
We
idea
can
of
also see
how
the
this
concrete
reinforcement has been
deflections of the
generated
beam.
and if it covers the bending moment
For this
diagram.
particular
You can
parameter,
also access the
advanced design does not
deflections.
simply produce the
Uh,
deflections based on
these
the
are the
deflections of
deflections
the
of the
finite element.
concrete. The advanced design has the opportunity to run multiple iterations in order to get the real deflection of the structure.
And finally,
And finally, as we mentioned, for the columns, we still have the interactive drawing for the beams as well. So by selecting drawing,
given by advanced design for review can be generated for beams. The same
the
principles
interactive
may
drawing is
apply for
generated
the
now.
reinforcement drawing,
Again, the
and
same
the
principles
forms
apply
of
here as
the
well.
columns
So
apply
you have
to
the option to modify the reinforcement, and the drawing is updated real time without launching any
again the
calculations again,
document
and
is
this saves so much
interactive,
time
which means the results
from
the
for an engineer and for a
reinforcement on
team of
any
engineers, because
section.
they don't have
The
to
drawing
wait
is
and launch any
updated
calculations again.
without
They
launching
can
any
access the
calculations.
reinforcement and
The
play
final
with different
module
options of
last
reinforcement
today is the one for the
for the
slabs. This module
beams. Here
allows for
is
calculation of
the
longitudinal
slab module.
reinforcement for both
We will see
directions
how we
for a horizontal plan
do the reinforcement for a slab.
element.
Here
We
is
have a
the
similar interface with
theoretical
contiguous
reinforcement
modules
for
and
the
allows
slab.
the engineer to calculate the reinforcement easily and effectively. We can see the reinforcement diagrams on the slab with the values of the reinforcement. We can also see the reinforcement gauge for this
This
slab,
is
the
the case of
reinforcement
the reinforcement
diagrams
on the
on
slab.
the
We can
image of
have
the
a
slab
comparison
so
between
we
those
know the
two
values of the reinforcement,
in
and of course an interactive drawing can
screen
be generated as
side by
well.
side, and of course
The
the interactive
same features and
drawing.
properties as mentioned for the
The same properties and same features for
interactive
the
drawings for
slab
different
module
structures and elements.
apply for
Last but not
the
least
same.
is the footing design
And
in
finally, we
advanced design.
can
After
design a footing.
plotting the forces
This is the
on
last module I
the
will
supports
address today.
for
So
this
first we can see the
structure,
reactions at the
as we can see
supports
here, using the
by selecting all these
results.
parameters on this tab here.
We are now ready to
And these are the information coming
the following.
from the
We
advanced
have
design
the design
interface before
for
moving
any of
to
the
the
footings. I will
footings
select
module in order
the
to address the design of the footings
that
specifically.
has
I
the
will select
highest
the footing with the highest
stresses,
um,
and I will perform the design. I will export this
force,
footing on a module.
and another
From the
module
design
will open.
here, we
Same
have
principles,
dedicated
same
module
interface.
for
You can see the
the
footing here.
footings in advanced
We
design.
can change the footing type and
The same
geometry.
principles apply
Normally,
here as
this
well.
comes directly from the advanced design. All this information come from advanced design because
Defined here.
we have already
The
selected
outer
them during the modeling
is on the
process,
left side.
but you
We
can
can
change
select
them
different
easily and
textures.
effectively in this
Change
module,
the geometry.
and
The
this will not
geometry of the
interfere
results
with
fade
the modeling.
from the
As you
advanced
can see,
design
we can use
module
those
and
tabs on the
the
left to change the geometry of the footing.
we want.
And another
In addition to
feature
this,
that is quite
we
nice
can
is the soil
use the
profile.
soil
So if
profile
you have information for the soil
and
profile
then launch
and you would
the
like to take that
calculation
into
for this
consideration when
footing.
designing
So
this
I will
footing, you can
select
select on the
the default
third
soil
icon and add your soil profile. In this case, I'll keep the default ones,
and I will not
and
change
all
any
the assumptions will be the default
reinforcement
ones, and
parameters on the soil.
I will
So
launch
click
the
calculate
calculation
in order to get the
reinforcement for the footing. And here we are.
on the right hand
This is the
side. You
reinforcement
can
for the
see
footing. On the right-hand side, you can see a 3D view of the footing of the column with the reinforcement generated. And on the bottom, you can see a 2D view with the cage. And of course, on the left-hand side,
and of course we
we
can
can
see
see
the
a
stresses. We
section
can
with the
see the
reinforcement, of course,
results of the
generated.
reinforcement as well. And again, clicking on the results,
We can access the results and we can generate an interactive drawing, as we have discussed before. It has the same properties as all the interactive drawings generated so far for columns, for beams, for slabs. Is a very nice tool.
The same principles that apply to all the other interactive drawings generated from different modules apply for the footings as well. And any modification on the reinforcement of the footing can generate
While
a
this
drawing
drawing
again
is loading,
without touching
I will
all
repeat
the
again.
information.
We can modify any parameters on the reinforcement, on the spacing between the links, for example, or the diameter of bars, and this will be applied directly on the drawing. So you have the option to play with many different generations of reinforcement, create as many drawings as you want without having somebody to draw all those for you in AutoCAD. And this saves you
The same
first time
more or
and
less
also saves in human power
used
as well, because they
is
can
before
work on another task
on this
instead of just
drawing,
generating
and of course the
and drawing
information
reinforcement for you.
generated here.
And
The
finally, I will show you a
footing,
few things
we
in
can
um,
have
footings as well. We have this
any side
stability
by
icon where you can
any
see any
sliding or overturning
instabilities in your footing, for example, any overturning,
footing,
any
and all
sliding,
these informations
and you can
are
have
depicted
an
in both
in-depth
the
idea of what is going
analysis
on
this
footing.
tab, and also
And on
we
the
can
analysis tab,
access the analysis
we
of the
can
footing and
access
get
the
information regarding
design parameters that
analysis
used
of
in
the
order to analyze and design this
area,
footing. So you have an idea of what
any
was the internal
there are
forces used,
combinations
the
to analyze
supports
this footing,
forces
the
used,
internal forces,
and
the
all
Boolean
these
that the student
parameters that
used
affect the analysis
to
of the
analyze and
footing.
generate the reinforcement for this footing. And of course, all this information can
And of
always
course, we
be
can have a report for that. We can
on
click
a
on
report
generate, and a
to
report is
generate
created
this
for a footing again,
before
as
finishing this
for any
webinar,
other
I would
element.
like to
So
explain the
before
footing
finishing this
and
webinar,
about
as
one
I
particular
promised,
phenomenon
we will
that
discuss two significant
exists
phenomena
in
that occur
reinforced
in
concrete
reinforced concrete
structures
structure.
and how
The
we
one
can
is
remove
cracking,
this
and the
from
second one is the
reinforced
punching
concrete. The first one
shear.
is the cracking, and the second one is the punching shear. First
In
of all,
order
I
to
would like
create
to
some
modify
punching shear effect in
the
this
structure in order
structure,
to
I
create
would probably
a
need
punching
to
shear
remove
effect on this
one of the
slab.
beams
I
in order
will need to
to
remove
create
a beam.
the effect of punching
So
shear, having some columns
the
connected
columns are
directly
connected
to
directly to
the
the
slab.
will have
So
this
I will remove
effect.
the beam or
So I will
some
remove
any
the
of the
slab,
beams of the
this
slab
part,
of
I will
the
hide it, and I
second floor
will
I created earlier. So removing the slab of the third of the second floor, I'm
remove
about now to delete this
this
beam
beam.
and create basically the punching shear effect on
Removing
the
this
slab of the
beam,
second
the one will
floor.
be connected on the slab, and we will have a punching shear effect on the slab of the second floor. I will bring back again the floor I hide it and the slab, and I will launch the reinforced concrete design again in order to show you how we can access any information regarding the punching shear on the slab. Before doing that, I need
In order
to
to
explain those warnings
take into
about any
consideration
stops,
any cracking
and basically
and the punching shear
today we will deal with
effect,
cracking.
we need to modify the
As
assumptions
we
of the
said
reinforced
before,
concrete design.
on the design
So,
templates,
accessing the design
for the beams, for
templates,
example,
for the
a
beams,
particular
I'll
section
start with
of
the
cracking,
cracking. We have this particular
and
tab
in
for the
this
cracking,
particular section,
where
we
the
can
correction
define
of
the
the cracking
maximum opening
opening
for
needs
the
to be
crack,
enabled.
and
Basically,
we
what advanced
enable
design does
the
is take
corrections
into
for
consideration the
cracking,
reinforcement that has been applied
which
in
means
order
that
to
the
calculate
software will
again
take
the crack
into
opening
consideration
and decide
the
if the crack opening is too large,
reinforcement
exceeds the
generated
max
for
crack
the beam
opening.
for the slab
And with
in
this
order to specify
option, we will
the
get rid of all those
structure,
errors, all
we
those
can
warnings.
check
And
if the
of
crack
course, the
opening is different
crack
from
opening
the
that will be
maximum
calculated will
assigned
be the real one, because in this
uh,
case, we get this error, we get this message
assumptions
that the
of
crack
the
opening
reinforced concrete design.
is too large, but the reinforcement has not
For this
been
particular
taken into consideration
warning
because we
statement, I
haven't
need to check
applied
that
this
all these
correction.
elements
As you can
have
see, we get this
the
warning only
correction
for certain elements.
applied.
So
An
basically, we
easy
need
way
to
to check
check
is
if these
basically
particular
apply
elements
the cracking
have this
correction
type
to
of
all the
cracking
linear elements.
correction. For this particular
For example,
webinar, I will not
for the
just
beam
search all,
figure
I will just
2,
try to apply this correction to all elements, just to be on the safe side, just to make sure that all the
I
elements
will
have
check
this
that the correction of
correction
cracking has
of
been assigned.
cracking enabled. Normally, I do this only for the beams and the
I also
slabs,
for the slabs,
the cracking correction, because it's the elements that they are more prone to cracking. And basically, I go through to all the beams and slabs
and
on
now
each
we
floor.
continue
I
to the
select
second
them
floor.
all and I
On the
apply
first
the
floor, doing the same
correction of
process
cracking
as the
to
first floor.
each of them.
And the slab of the first floor. And for the second floor. And lastly, for the slab of the second floor. Finally, we
Finally,
need to align
before
the
launching the
punching
reinforced concrete design
position
again, we need to
on
take into
the
consideration the punching shear
basic
effect. So I click on the punching
launching.
verification
For launching
on
the
the
reinforced concrete
design
design
settings
again,
and
in order
selecting
to see the difference
the
all these
slabs again,
assumptions I
I
assigned have
need to go on the
different
punching shear
results.
tab of the elements and enable the punching shear verification and calculation. So I launch the design again, and we will see now how we will deal with cracking and punching shear in advanced design. And first of all, we will see that first we will get rid of any warnings, because the calculation of cracking we will be correct now. We have assigned the correction of cracking. And of course, I will show you how we access the punching shear effect on the slab of the second floor. The Because I'm running the reinforced concrete design again, this might take a few minutes to be completed.
The calculation has finished, and as you can see, we have
The
no
calculation has
errors
finished
regarding
in
the cracking. This
very
means that
quick
the
time, and we
cracking
get rid
opening,
of all
the
those warnings
maximum cracking
because, as I
opening,
said again, the cracking
is
has
not
been
larger
now calculated
than the
correctly. Take
maximum
into
cracking
consideration
opening
any reinforcement being
defined
placed
in
on
the
those elements. You
assumptions
can always access the
uh,
cracking from
for
the reinforced concrete
punching
design
design. We
results,
can
and you can
always
always
check
check
and
if
access the information of
the cracking
enhanced
width is
concrete
below
tab,
the
and
maximum.
finally we will see how we deal with punching
And now we
shear
are
in
about to
advanced
see how we
design.
deal
So
with the
clicking
punching shear.
on
So clicking on
documents
documents and generating a
and
report.
generating a report.
This is the only way to check the punching shear
On
results.
this right
you
hand
have
side,
to select
we can access the
tables.
tables and always check
The
the
reinforced concrete
concrete
analysis
matrix.
tab on
And
the
on
tables
the
and the
results,
results.
we can
By
access
selecting
the
the
punching
punching shear verification
verification
and
and
punching reinforcement,
reinforcement.
you will generate those two tables, and you will be able to access the information um, being on those tables. The report has been generated. This is what to expect
Generating this report,
when
you get all the
creating
information on
these
the
tables, and these tables
punching existing
contain all the
in
information about the punching shear. So you see
these elements.
the
As you
element
can see here,
that
this is the
has
plate, this
the
is
punching
the
shear
alloys
effect,
housing the punching
and
shear on the
then
plate.
you see all these
All
elements
those
creating this punching
different
shear effect on the
parameters,
planar element,
they
and
are
all
used in
those
Eurocode
parameters that
to
the Eurocode
to
has and
define
requests
the
to
parameter and the area
calculate
of
in order to
intercept
deal
of the
with punching
punching
shear.
shear on the slab.
In our
As you
case,
can
as
see
you
here,
see,
there
we
is no
have
property of
OK everywhere,
punching
which means that we don't
here
have
for this
any
particular
punching
design.
shear
But if we
failure,
increase
which means
the
that no reinforcement has
load,
applied
probably
because
we will
um,
have
the
to
effect of punching shear does not
punching
need any
shear or
reinforcement.
add a
However,
punching
if I would
reinforcement for this
increase
particular
the
tolerance
load, or if
load.
would, for example, apply any
In this
point load,
particular
would be
design,
able to
I
see a failure and add a
assume
reinforcement
that
as well.
the reinforcement that
The
is
advanced design has the option to take
in
into
the slab
consideration
has been
the existing
accounted
reinforcement
for
of the
the
element
punching
in order
verification.
to
However, there is no
do
option
the punching
to
verification or ignore
locate
it.
this
It's up
into
to you to
consideration
decide if you would
and
like to take this into
perform
consideration
the
or
correct
not.
analysis
All in all, the
without
punching
taking into
reinforcement would
consideration
be
this reinforcement.
still reinforcement after all.
Finishing this
And
webinar,
finishing
I
this
would
webinar,
like
I would like
to
to conclude a few
present a
things.
few
The
conclusions
benefits of
regarding
advanced
advanced
design
design.
is an
First of
easy
all,
software that
the
allows for easy
benefits of advanced
modeling.
design, it is a
And
very
as we
user-friendly
saw, you
software.
can
The
use
modeling can
many
be
different
very
features.
quick
You
and
can
effective.
copy and add
There is a
elements
wide
very
variety of
easily.
load
We have a
gauges
very
in
good
advanced
wide
design,
variety of different
and
loads
the
to add on your
meshing
structure,
capabilities
and the meshing capabilities
are
are
quite
quite
interesting.
fast and
The
interesting.
measure is quite fast and is a big smoothing as well.
The
There is
concrete design, as
concrete
we saw,
design for
offers
different
a wide variety
structural
of
elements from beams
modules
or core of a slab.
to
Punching
work
shear
with.
and
So we have the
cracking is
beam,
also
the
taken
column, the
into
slab. We
consideration,
deal with
as
cracking
well as
and
the
punching here as well, quite
total
effectively
deflections
and
of the concrete.
easily.
The advanced design
And
modules
the
for the beam, the
the
column, the
modules,
footing,
as
and the slab
I
are very
mentioned before, and
effective
I will
as
conclude
well.
again, that they can
Data are
offer
generated
a wide variety of
immediately from
information
advanced design to the
that you can
module,
access for each element you would
and
like to
the
design. And at the same
Eurocodes
time,
and all
you can
the
have the
requests from
interactive
the
drawing, that is
Eurocodes
a
are
very nice feature and
incorporated.
very
We have the interactive drawing
for me
coming
and
from
for
this
anyone
module,
that's
as
an
well as
engineer.
detailed reports and all
And you
those
have the detailed report
important
as well.
information we discussed throughout this webinar for each of these modules, for the beam, for the column, the footing, and the slab. And finally, the benefit these modules have is how easily you can change and modify things with the
Another
geometry,
benefit,
like
as we mentioned, is
the
the how
reinforcement.
easily you can
Anytime you
modify
want to use
parameters
the
on these
modules
modules. Although they come directly from advanced design,
separately
you can easily
without watching
change
the
those
whole
parameters
calculation taking place
effectively,
for this particular
and you can
structure. This is
launch
a
the
very
the
important feature of the
generation of
modules,
reinforcement or the generation of the
and
drawing
saves so much
instantly
time
without
and
having to
energy
launch the
for
whole calculation
from the
again.
structural
And
engineer.
you can save so much time using these two features.
To conclude,
And these
the
are
advanced design is a
the
very user
conclusions for
friendly
the
software.
use of the
It can
advanced
perform
design. You can is a very user-friendly
analysis of
software. You
reinforced
have so
concrete
many
structures
options
quite easily and
in terms
effectively,
of
and
the
there
modules
is
you have in order
basically
to create the
a
reinforcement for
solution
your
for
element,
a
and at the same
structural
time
engineer
it has the
that
option to deal
targets to
with phenomena such
a
as the
safe
cracking and the
and
punching shear
effective
quite effectively
design
and
of reinforced
easily.
concrete structures.
And
Thank you very
I
much.
believe is a very good solution for someone designing reinforced concrete structures. Thank you very much for your attention, and I'm happy to take any questions, and I'll try to answer. Thank you very much. I would like to apologize for any inconvenience caused in the beginning with the sound problems. I hope that you enjoyed the whole webinar and you have probably a few things to discuss or any questions that you would like to share with me. You can write your questions on the Q&A so I can access them and try to answer them. Also, as I said in the beginning, you can leave your feedback. Your feedback is very important for us and it helps us to get better. And I would request for your feedback as well. And also, you have the option to request a demo if you would like to use the advanced design for on your own and see and play with the features and see all those things we discussed today. How easily you can do it on your own. So feel free to do that if you want to. Since there are no questions on the chat, oh, okay, is the webinar available for review in the future? Oh, can you explain? I'm sorry, your question just gone through. So can you explain why there is a hairline cracks seen in UK houses? You mean I'm trying to understand your question. You mean how we can deal with this in advanced design, or let's have I'm not sure about your questions though. In terms of hairline cracks in UK houses, is it a kind of a theoretical question? Because I can't figure out the question in terms of the advanced design aspect, because it could be due to, I don't know, I mean, cracking is hairline cracking can happen when you are designing with uh, with concrete. It normally comes from the concrete becoming solid. So you would expect some cracking from that. I mean, if it is a hairline cracking, uh, in a country with earthquakes, somebody would think the earthquakes, but in the UK, it wouldn't be the case for this hairline cracking. I would be happy to answer this question if you want and you want more information. You can send me an email and I can come back to you with an email about this particular question. Okay, yeah, it's not in terms with advanced design. I believe it has to do with that, with the solidification of concrete. So normally when it solidifies, you have stresses coming from something that becomes from liquid to solid. So you expect this kind of hairline cracking, but no, that I don't think it has to do with advanced design. Yes, true. How can get access to the demo? Probably on your screen you will be able to see an icon where you can press and request for this demo. And however, if you are interested in, you can probably send me an email and we can sort this out for you. I am speaking to Tariq, if I'm pronouncing your name correctly. If you would like to access the demo, please send me an email. I can share this on the chat here, or you can find it on my bio as well. Is the webinar available for review in the future? I am not quite sure about that. I can discuss that with the people responsible for this webinar, and I can come back to you and let you know if you can have access to this webinar for the future review, or it is restricted and you can only watch it when it is online. So I don't know if you have this option, but I can come back to you if you want to. Any other questions? Okay, quick update. Yes, the webinar is available on demand. So on the same link, you will be able to access this webinar again and watch it again if you want to. I just see a message that says can't hear you. Did you get the explanation about the hairline cracks, or do you want me to repeat? Please message me if you want to, because I was probably I was speaking quite silently. I can repeat, however, in a few words. So, as I said, it has to do with solidification of concrete. So, yeah, these hairline cracks can be attributed to that. I hope that this resolves your question. I can I have your email address? Yes, I can probably write that on the. I as I see here, my mail address is on the bio. So you can probably access this information on the bio. However, I can try to write this down here. I see if I can. And if you have this option to read my message.